All right, here we go. Thank you for your patience. We'll go ahead and get started with the next session here. I'd like to introduce Nate Day, who is at Eezy, I believe is the company, which is a stock image marketplace, and he does something there. And his bio on our website is that he dances in vector space. So he's a man of mystery, and he would like to talk to you about multimodal models today.
Hopefully, you'll have some fun with this talk. I know I have making it. Thank you for the introduction, Patrick. My name's Nathan. You can say Nate, save a syllable. I'll respond to it. I'll respond to lots of things, actually, but let's not do that until after the talk, please. So this is work I'm presenting, but it's not really work that I did all myself. I did this as part of a team. We're formerly called the Data Team. I prefer to refer to us as the Data Wranglers, kind of like we're a bluegrass band. But we're spread across all across the U.S., right? So we have someone in Greenville, South Carolina, someone outside of Birmingham, someone outside in Bowling Green, which is where my company is based. We're kind of a remote first org, and then someone all the way out in Colorado. And Adam Gamble is our CTO. Kenan Bayou. I let everyone pick their own emojis. I seeded that, and Kenan was the only one that wanted his to have a mechanic with a plunger was his choice of how to describe him. He's a fantastic app developer, fantastic data engineer. And then we have Ryan Garris, who's kind of like a SQL admin wizard person. You have me. I do search stuff and a little bit of science. And then we have Chad, who's kind of our business forecast, ad revenue expert. So this is not all my work. I could not have done it without these guys. So giving them a little shout out at the beginning. So what do we do at Eezy? The goal here for us is to really just let people express their creativity, right? We're a stock art marketplace, and most of our customers are designers, right? They don't have to all be pro designers. They can be freelancers. They can be working inside for a corporation, right? In-house team designing stuff for ad flyers. They can be outside. Lots of education. People use it to build lesson material. Lots of EDU. And then lots of people just messing around on the weekends trying to build beautiful birthday invites and birthday picnics and stuff like that. So you can do a lot of stuff with our site. And really, what we want to do is make it easy. So we're in a space similar to Adobe stock, Getty stock, and kind of like a crossover with what Canva does. We have some online editor tools for you to make things, well, easy. And that's why we're there. And so why am I at Eezy? I'm there as a search person first and foremost. And I think we've all heard this phrase, a picture is worth 1,000 words, right? So why are we all still searching with text? And I think that's one of the things that we've really been able to change over this brief timeline. And we're going to cover that here together today. So has anyone here used Circle to Search Android? Does anyone here have an Android phone? I'm just Charlottesville jokes. So it's really powerful. It's only on Android right now. If you use Google Lens, you can get access to something similar. But it's really cool tech, and Google's been running ads all over the place for this. Sorry, I don't want this to run. Sorry, there's in there if you want to watch the video. But Circle to Search is kind of launched January 2024. This is the horizon for us today in the next 20 minutes here, and you're there if you need a reference point. The first step we want to talk about is this thing called Clip. Has anyone heard of Clip? Has everyone heard of Clip? A few people have heard of Clip. So Clip is really this watershed moment in terms of deep learning from the internet, and it's a really elegant idea, like all kind of big things seem to be at the end. And it's about taking contrastive loss between an image encoder and a text encoder. And essentially everything on that diagonal there in the left panel is supposed to be similar. You train the loss function to reward that and push the other things away. And what you get at the end is a very, very powerful, state-of-the-art powerful zero-shot image detector for classification tasks. And how powerful, you might ask? So Clip is old now, 2021, ancient. But it absolutely obliterated the state of the art when it was released. So this is a big step forward. And why it's such a big step forward is really because no longer are you constrained to using labeled data, right? The whole beauty of this contrastive thing is if you have any alt text, any caption that goes with any image on the internet, that is now trainable data, right? You have a text, you have pixels. Contrast those two together, figure out what the pixels are telling you if you're using the text essentially as the label, right? So kind of the idea of like weaker supervision, but I mean these gains are massive, right? So ImageNet has been around forever. We're going to keep talking about ImageNet. Sorry, this slide's a little hard to read, and we won't spend too much time on it. But OpenClip was essentially, Clip was developed by a company called OpenAI. Probably heard of them. Surprisingly, OpenAI didn't release all of the data or all of the training steps they use. Surprise, surprise. There's competitive advantage out there. But what they did do is a bunch of people in the EU went out and said, hey, we're going to actually reproduce this thing. And engineers from OpenAI helped them do it. So this is a standalone project called OpenClip. These are some useful pieces here, right? You can see OpenAI's clip down there highlighted in blue, OpenClip here in green, and what you have in the kind of the columns that really you should pay attention to are number of samples and then that accuracy on ImageNet at the bottom. And you can see this space, it isn't totally done kind of developing. Google released a new iteration on Clip they called SIGLIP. I put an extra C in there, that's a typo. But it's about how to speed up Clip training on large data sets. So same architecture, and it's really kind of cool that this became open source because it frees us all up to do things like this, give talks like this, use this in commercial products, etc. So open source is important, and I think we'll see with all of these models, open data is equally important. So just a quick overview of how these things kind of like size, scale. You can see accuracy goes up on the Y, as well as parameter size of the model goes up on the X. It's not linear, it could be log linear, but you get really big really quick, and the gains diminish somewhere in there. Just an interesting bit here before we leave is what happens here in those two highlighted versions is the first clip they released was trained on 32 billion images. It got 75% accuracy. Someone came out with DataComp, which is a subset data set of that 32 billion. It's only 13 billion, and they trained on that, and accuracy went up. So we're at this time where we've lived in this big data, more data, all of this stuff is better. If you think about some of the stuff like peak data or data exhaustion, things like this where you're restricting the training data to essentially cleaner parts of it show increased model performance too. So I think maybe scraping all of the internet for things, turns out there's a lot of bad stuff on the internet, right? Surprise, surprise. So this is kind of where these guys are happening in the talk timeline, but essentially you can see all of that was really what's powering this circle to search thing that kind of launched 2024. So let's tap into that. And so at Eezy, the first thing we tapped into with it was reverse image search. So we had a reverse image search thing in there before. It was a convolutional neural net, like lots of things are with LSH hashing kind of search functionality on it. And so all we did was we really change that CNN to that clip feature extractor. And these are the results kind of that you can see between the two. So that image up at the top is a loon. It's kind of hard to see in the darkness of the movie theater. And then what comes back from the Eezy search there is images of other loons. Eventually you get to other aquatic waterfowl, or just waterfowl, maybe not aquatic waterfowl. But and you can see on the bottom what you get is a bunch of other waterfowl, but no loons right away, and they're all on water. So the big change here is that Clip is paying attention to context. It's moving beyond just having pixel to pixel similarities, right? So you're not just getting a water background, you're getting a loon. And it's not crazy in this example, but it means a lot when you go forward with reverse image search. And so what ended up happening was our reverse image search got out there. A creative blogger actually picked it up and wrote a nice blog piece that I have linked up just about how much better it is than our competitors were, which is a big deal for someone like Eezy competing against people like Getty and Adobe, people with much larger tech budgets, much larger teams. But when it came time to A/B test this, it was so blatant to everyone that it was just better. So we didn't even test it. We just pushed it out. And it's not a large traffic thing for us, so we weren't super worried about it. We didn't have to do any extra engineering in terms of that server side to serve this content. We just had to embed everything, which is its own challenge. But that's for Kenan with the plunger to figure out. So this is where we were with reverse image search. So this is kind of, I started Eezy in February 2023. And so May 2023, we're already launching new stuff based on this. Always good to hit the ground running. The second place we went is to the search bar, right? The reason we didn't go here first was because this one's a little bit more risky, right? We rely on Google, just like everyone else on the internet does, for a large share of your traffic. If you change your search algorithm, suddenly everything that Google has been crawling could be different. It could be worse. Things could shift. You might not gain as much favor as you did in terms of their ranking of your content. All of that stuff is critical to our business. So we punted, but we realized that we needed to get Clip in here somehow because kind of the system, it's built on token scoring and token matching, has always been plagued by token mismatches or vocab sparsity problems, right? You're a creative, you're coming to describe this kind of idea that you want to see, and we still had to either, one, enrich our own content or rely on a contributor to give us highly searchable quality vocabulary that the searchers, are also going to use themselves, right? And that vocabulary mismatch problem, it's a very old search problem. And all of this stack is done in Elasticsearch, not super important, but it's just calling out the fact that when you move to something like this, you don't necessarily have to go migrate to a vector DB. So Clip Score is our first. We tried to get Clip in here, and we said we did some work earlier at a Trek competition for text search on podcast transcripts, and we found that if you did roughly like a 50-50 blend between the token score, BM25 base score, and embedding similarity, that was a BERT model instead. It turned out, and we ended up winning first place just with that kind of elegant mashup, if you will. Half of this equals something that has hybrid vigor, right? It's stronger than either one alone. It also came out that you didn't have to re-rank, you didn't have to run vectors first. You could use vectors as re-rankers, which is much, much cheaper and much less prone to errors. 10. Cool. So the idea here was we're going to just profit, right? Reverse image search was huge. This is going to be great. We're using face that doesn't blow up well, but it turns out it was not perfect. So downloads tanked, right? Search pages, the number of pages the average search went up as well. So people were kind of like frothing, essentially. We're losing people in the mix. And what happened was we were kind of corrupting that behavioral signal, right? We have really, really rich behavioral signal of what people want, and Clip was coming in and saying, actually, I think we should put these up on top of that behavioral signal. And that clash, that's kind of why I have the boxes-ish height, was causing problems. So it actually, the next 4 A/B tests we did, the next 4 algos we ran out, also all failed. Not quite as miserably. We were getting closer and closer and closer, but still failure. So starting to wonder what happened with that podcast thing. Is this possible? And so then we land on this kind of alternate architecture, if you will. And so now not just tokens, but behavioral score, Clip, all of that can get stuff into recall. That's what those lines going down to the bottom are. But really, if you have behavioral score, we want that to be what you use over Clip Score, right? Trust people, don't trust AIs. If you take anything away from this talk, that's kind of what we learned here in the search algorithm. And it makes common sense. But when we hit it, we hit it. And not only does this improve search relevance, it also improves revenue. People can find more stuff. People buy more stuff. Weird. But massive win for the company. Where does this win come from? What I have here is faceted. There are two plots. We can just focus on the right column. But I have the rows split up between low, medium, and high user signal. And it's really only in that low signal panel up at the top where you see any departure from Clip versus the current production, right? So again, behavioral signal is key. It's the gold. You're getting people to label data. Use it, right? So, but it's all a long tail. So just little slight wins that kind of came with Clip that we knew were coming, but were also massive in terms of search engine ranking. 0 results goes to the floor. Doesn't mean they're always good results, but lots of times if you're a search engine, it's better to return something than nothing. Let them decide if it's bad. And then this is also conversion checkout values across different tiers of countries post-launch. And so everything kind of does a little moonshot, which isn't bad for a search algorithm, right? That's search bar there. And then if we continue, you have other so this is another idea called Blip, which you guessed it is built on top of Clip, and it's essentially an image captioner. So all you train in this architecture is this thing called the Q-former, that thing in the pale yellow. The image encoder and the language model itself are frozen. That's what the little snowflakes are there. And they're off the shelf essentially from someone else's. Anyone want to throw out a guess to what image encoder these guys use? It's Clip. Shocker. At least you can tell. So anyway, we're using the same image encoder. We already have these embeddings. Why don't we just take these embeddings, feed them through their Q-former into an LLM, and we can start to generate meta content to go along with this stuff too. This has been an old paradigm for like search for a while, where you actually enrich documents with a model. T5 is a great model that does this, and it yields really useful results. For us as a stock image company, this is really useful when someone's uploading hundreds of images from multiple shoots. They don't want to go in and tag all of those with everything. So we offer a tool that we call Magic Metadata that will let you just upload your images as a creator, give us a day, we'll update captions, tags, all of that stuff for you, and show you what it looks like. Super nice and useful for 5. So this is this idea called Token Scrubber. I'm going to skip Token Scrubber just so we have some time. But there's also the idea is that lots of people keyword stuff essentially as Token Scrubber, and you can cut stuff out with Clip as well by using these similarities. You can say this tag doesn't apply to this image. Other things you can do with Clip are use linear probing on top of it. So this is an example of a style detector we built. And what happens in that is you feed it an image with this large Clip embedding into a very simple probe layer. It's essentially a single fully connected layer, also a neural net, right? But it outputs a set of known labels for a multi-classification problem, right? Super useful for categorizing stuff and enriching data, right? And all of this is kind of coming off of the exact same Clip embedding. You can see some examples here of images. The label, you do need labels for this, and then the predicted labels output. And you can see some situations where the label is on the top row, and then the predicted output is on the second row there. So the model does an exceptionally good job at this. And it makes sense, right? This information should be contained inside of that the Clip embeddings, right? So these things all kind of shook out right here across the timeline pretty good. You can also do this for categorization. So you can take the embeddings themselves, cluster them. We use a k-means algorithm to define 50 centroids in this example, and then use hierarchical clustering on those 50 centroids to get a sense of how these all stack together. It turns out it works pretty well, and these are these kind of naive clusters, latent clusters in the space labeled by the most frequently occurring tags in those spaces, and you can see things stacking right on top of each other, right where you would expect. But just more indicative of how much information is stored in these Clip embeddings themselves. You can also use this for user recs, the same embeddings. And so you take, these are hard to see, but each one of these users is the last N downloads from a given user, and they're pretty diverse. People don't just download all one thing, except for this guy who really likes electrician photos and interior design photos. But most people are kind of all over the map, right? You're doing something here and then something over there. So if you take the Clip embeddings, run it through another k-means algorithm, you get individual centroids which correspond with their individual kind of like search themes over the course of this too. And so here you can see what happens if you have k equals 1 on the left. All the images end up being very homogeneous, one centroid. Everything close to that is similar. But as soon as you expand that to a k like 3, you get kind of 3 distinct different flavors of images for recommendations. You can imagine this is a much more appealing stock when you're starting to sort for giving someone new images to think about. So that's where we are there. Looking at Patrick for my time. And then the last thing here is what I want to introduce as Borges. And there's this famous story Jorge Luis Borges wrote, Library of Babel, and it's about this infinite series of library rooms. There's a bunch of librarians in there. They're all just looking through these rooms, trying to find the truth. It turns out it's hard to find the truth in infinity, and you end up spending a lot of time looking. But let me see if I can do this on the other screen. It might be too hard with the cursor. So we actually have this tool here. So like we've talked about how much stuff you can use this vector space for, and I really wish I was on screen mirroring now. But the cool thing you can do with vectors is you can average and you can weight them. So what you can do, and also with normalized embeddings, you can do things like inverses of different things, and you can go and change components. So if you just look up, I can't even read what I have in the top of that slide over there. Babel is all the way on the left in library. So if you have just Babel up and library down, you get cakes. You can go through and kind of infinitely explore this space. You can add images, right? Images, text, all of it's an embedding. So you can kind of play and explore. And this isn't something we've released publicly because we're really unsure how to fit it into modern UI, but I just wanted to leave with this idea that I think with vector search, lots of modalities, we could explore new ways to search, new ways to get stuff in front of users and kind of give people more control, right? This is a situation where you control the weights, you control the terms and the components. You're not relying on something to interpret a short text query for you. So thank you for listening, and I'm going to wrap up there.
And if you play with these tools, maybe you too can dance in vector space.
That's how you do it.
I think we have time for a few questions. I do like the cake here. If you just have Babel and anti-library, you get cake.
It's surprising. I would love to do the center of the universe, like flip universe at least, turns out to be like red carpet photos. See if I can just turn these guys into
Oh, if you just have nothing at all.
0, 0, it turns into like Katy Perry.
I do like that cake that sort of looks like the tower right there.
Yeah.
Or what
So
even
like
is that?
sliders was something that was kind of surprising to us doing it, where we were really like, okay, well, how different will these things be? And we just start kind of changing the weights of them, and what you see changes wildly, sometimes very wildly and unsurprisingly so, but still just super interesting stuff.
All right. Any other questions? We've got one. Here, I'll bring you the microphone, and I think you can use the desk mic.
When you're doing such experimental stuff where the user is also experimenting with how they would search, how do you evaluate it?
So a lot of what we do for this stuff, we don't even try to. This is just kind of a fun design tool, and we'd put it out under kind of like a Skunkworks label. But your question still has a lot of really good starts in it. So what we do is we go back to that behavioral signal. So whenever, like for that style detector I skimmed through very quickly, we used past searches that involved one of those style keywords essentially to kind of label that data set for us. And it's pretty easy to do. You only need a couple thousand examples for something like that linear probe. Maybe not even 1,000 really. And it's very fast. But
Is there a question back there, or was that big?
I can
Okay.
hear you.
With the ability now to train AI models through LoRa and various other concepts, how do you feel that will affect your service? Where I can say, take these 10 cakes, you'll learn the concept called cake, and then throw in these other types of prompts on top. Talk about that.
Yeah, so I mean, ever since I kind of came into the stock art space in 2023, and everyone was kind of like, yeah, Gen AI is going to kill stock art. And what we've seen in our catalog is people like Gen AI, but we've kind of reached a saturation point, it seems like, in terms of download fraction for that. And there's still stuff where we want the real content still. Your question about LoRa's and training, I think that is kind of hopefully like the next generation tool that designers have at their fingertips, right? If you look at Photoshop and some of the infill tools there, they're doing a great job of that, where creativity, can kind of be sparked by, there's just more substrate essentially for people to use in that creative journey, right? That's the hope. So.
Any further questions? All right, I think we will wrap up there. Thanks again.
Cool. Thank you all.
The next session starts at 12:05.